Pyramids of biomass are graphical representations that illustrate the relative mass of living organisms at each trophic level within a food chain. These pyramids are structured with producers at the base, followed by primary consumers, secondary consumers, and so forth, as you move up the pyramid. The width of each tier in the pyramid corresponds to the total biomass of the organisms at that trophic level, providing a visual depiction of how much living material is present in an ecosystem at different levels of the food chain. The primary reason why pyramids of biomass are used is to convey the quantity of organic material available at each trophic level. Biomass refers to the total mass of living organisms within a given area or ecosystem at a particular moment. It includes the dry weight of organisms, excluding water content, and is often measured in units such as grams per square meter, (gm squared). By focusing on biomass rather than just the number of individuals, pyramids of biomass give a more accurate representation of the energy and matter present at each level of a food chain, since organisms vary greatly in size and mass. In a typical pyramid of biomass, the producers, such as plants and algae, form the broadest base. This wide base represents the substantial amount of biomass necessary to support the higher trophic levels. As energy is transferred from one trophic level to the next, much of it is lost through processes like respiration, heat, and waste. Consequently, the biomass at each successive level diminishes, leading to a narrower tier in the pyramid. For instance, the biomass of herbivores, primary consumers, is smaller than that of the producers they feed on, and the biomass of carnivores, secondary consumers, is smaller still. This decline in biomass as one ascends the pyramid reflects the inefficiency of energy transfer in ecosystems, with only about 10% of the energy from one trophic level being passed on to the next. Pyramids of biomass provide valuable insights into the structure and dynamics of food chains. They highlight the dependency of each trophic level on the levels below it and show how energy and matter flow through ecosystems. For example, a steep decline in biomass from one level to the next can indicate a highly efficient predator or a large amount of biomass being required to support the next level, such as in the case of large herbivores that consume vast amounts of plant material. Conversely, an unusually narrow base might suggest an imbalance or a stressed ecosystem, where the primary production is insufficient to support the higher trophic levels effectively. Moreover, these pyramids can be used to predict the potential impacts of changes within an ecosystem. If a significant reduction occurs at the producer level, such as due to deforestation or algae depletion, the entire pyramid can be destabilized, leading to a cascading effect through all trophic levels. This makes pyramids of biomass a useful tool in ecological management and conservation, as they help scientists and environmentalists understand the carrying capacity of ecosystems and the sustainability of different species populations. In essence, pyramids of biomass offer a detailed and accurate snapshot of the living material present at each level of a food chain. By showing the relative mass of organisms, they provide a clear understanding of how ecosystems function, the flow of energy and matter, and the interdependencies between different trophic levels. This information is crucial for assessing the health and stability of ecosystems and for making informed decisions about their preservation and management.